Hello everyone. So in this video, we're going to talk about mathematical modeling. This is section 2.2.2 from your textbook. So we've talked about functions already, and now we're going to look at modeling with functions. And what that basically means is using functions to describe things that we observe in the world. So there aren't really rules or recipes that we would use to solve the problem, right? We're actually going to look at this more like problem solving, where there might not be one answer. There might be several ways to get to the answer. But there are some steps that we can generally take in order to get to our mathematical models. So in your notes, please write down these 4 steps. These are the things that we're usually going to do. We'll express the model in words, which is a way of helping us to understand what we want to model, how we can express it, and any quantities in the problem. So what numbers are involved, what values are involved. Number 2, we're going to choose the variables. We'll identify the variables, we'll use them to express the function in step 1. So thinking about what names can we give, what mathematical names can we give, like X, Y, Z, or anything else that we've seen before. Then number 3, we're going to set up the model. We'll express the other variables in terms of X. So I might start with many variables, but I'm trying to get to the place where everything is written as what happens to X. Then number 4, we'll use the model. That's going to be a way to answer the questions posed in the problem, or a way to find a solution to whatever we're looking for. And now you can see my face. Okay, I'm going to talk you through one example of how we might do mathematical modeling. This is example 1 from the textbook. It's asking us to imagine that we want to make a rectangular box with a volume of 2 meters cubed. So our unit is meters cubed. And it's going to have a square base, which means that if we look at this diagram, we can see that X is the length of the base and the width. Then we have some number h to describe the height. The first thing we're asked to do is to show that the height equals 2 over x squared. Well, if I want to do this, I want to first think about, what do I know, right? I know that if I want to find the volume of any square or cube or cuboid, I'm going to multiply the lengths of all of the sides. So the volume of this box is going to be x times h. Why is that? Well, it's because, why is that? Well, it's because we have here x, that's the one side, times x, the other side, times h. That'll give me my volume. Now, I do already know the volume, right? I've been given that in the problem. So I don't need to leave that as v. I can actually change it to this 2m cubed. So that means that 2 equals x times x, or we can write it x squared times h. And I want to write this all in terms of h. Well, I can't subtract x squared to the other side, right? Because this is x squared times h, right? I could even write it with that times. So in order to cancel it, I'm going to divide. I'll divide both sides by x squared, and that leaves me with 2 divided by x squared, and I'll put that in parentheses, equals h. And this looks a lot like what we saw in the first place, right? We have here h equals 2x squared, and now you see it the same way. So we've shown that already. And scene change. All right, so question 2 says, find a model to express the surface area of the box as a function of the length of a side of the base. What is this asking us to do? Well, it's asking us to try and find surface area based on one side of the base, which would be x. So we're going to write a function in terms of x, but we're not going to start there. We're actually going to start with the formula for surface area. And this is something that you might have seen before. So surface area can be described as the area of each side added together. So for example, if we're trying to find the area of the base, that's going to be x times x, right? And that will give us the area of this square here. Well, we're going to add that to all the other ones. So we'll have this x squared, but there will also be a second x squared at the top here. And there will be a side that is this x in the front times h, right? That's the front part. And that will happen again for the back part of the box. This is getting a little bit cluttered, so I'll clear it for the third one. We can also look at this x, that length, and the height, h. Right, that's one side, and that will be mirrored on the left-hand side as well. So when we talk about surface area, it's going to be 2x squared times 4xh, right? Because our surface area includes every single side. And there are two ones that use that x squared, that's the top and bottom. And then there are 4 that use x and h, because we'll have x and h for the front side, x and h for the back, x and h for the left and for the right. So that's our formula for surface area. We want to use this as a function of the length of one side of the base. This is where this gets a little bit tricky, because right now we have this written as a 2-variable function, right? We have x and h. So we want to rewrite this so that we only see x. And I'm taking that straight from the problem that says as a function of the length of the side of the base. Because the side of the base is x, that means that the function will be in terms of x. So I have this surface area formula already that says 2x squared plus 4xh. How can I change that so that we don't have h anymore? Well, that's where we're going to take what we found out in question 1. We know already that h equals 2x squared. So we're going to go ahead and substitute that in. When we substitute 2 divided by x squared for h, we're going to get a new formula, but it will still be the surface area. So we'll say SA equals, and we'll copy the same 2x squared plus 4x, and then the h will be that 2 divided by x squared. This is one way that I can express the surface area in terms of x. You could do other things with this, right? You could simplify it, and that would be fairly easy to do because we have here 4x times 2 divided by x squared. So that's something that we might get into next time. But I could even use this kind of messy formula to solve part 3. Part 3 says, find the surface area of a box when the length of the side of the squared base is equal to 10 meters. Again, we're going to ask ourselves, what does this mean? Well, it's saying that the length of one of the sides is 10 meters. And because it says it's a side of the square base, that means that x equals 10 meters. So we're imagining that this is actually labeled in our diagram, and we know that here's 10. So we're going to plug it into our surface area formula. And we'll say SA equals 2 and then it's going to be x squared, but we're going to make that 10 squared plus, and we saw there 4x, so it would be 4 times 10. Then that was multiplied by 2 divided by x squared, so that would be 2 divided by 10 squared. Go ahead and calculate all of this out. What number do you get? So when I calculate this out, I get 200 plus 80 divided by 100, which we can say surface area is equal to, when we add that up, it's going to be 200.8 meters squared. Or we can just leave it at 200.8. Now, if we were going to write this in function form, we might actually write it with f of x instead of writing it with SA for surface area. For example, I might say that my formula is f of x equals 2x squared plus 4x times 2 divided by x squared. Again, if you wanted to simplify this by canceling the x's, I think that would be a very good move to make, but I'm just going to leave it in this form. So this is something that we'll continue to practice in class. Go ahead and look over this example and really think about how you would write your function. Because like I said, for mathematical modeling, we can model in different ways and still get to a solution. All right, I will see you all in class. Thank you.